Hello and welcome to another episode of the Kielder Observatory podcast, brought to you by Kielder Observatory in Northumberland, right in the middle of the Northumberland Dark Sky Park. Now, it's been a busy time at Kielder Observatory, and it's a busy time in the night sky, even though the nights themselves are not particularly dark just yet as we head through the summer months. There is, though, the summer triangle that you can look for. We'll tell you what it is and how you can see it. Plus, frost has been discovered on Mars. We'll look at how significant that is and also just how big the mountains are on Mars. It'll blow your mind. And we talk about comets. There might be one heading our way, visible to the naked eye later this year. We'll have a look at how you might be able to see it and maximising your chances of catching a comet, hoping that it makes itself visible. But we'll talk more about that later on, and we'll discuss the upcoming sessions and events that you can get involved in at Kielder Observatory as well. I'm Ian Brannan. Joining me as ever is Dan Pye, Director of Astronomy at Kielder Observatory. And Dan, it's been a busy time, hasn't it, at the observatory? You've not been necessarily looking in the night skies lately, but for the last week or so, at the end of June, everything was shut down. You were scrubbing and drilling and renovating and gardening and weeding and all sorts and sprucing the whole place up. It's been a big old job for you, hasn't it?
Yeah, it has been. I dare say this has been the longest we've ever closed down for any kind of renovation work. And it's made a huge difference because we've gone from... I mean, I don't want to downplay the beautiful design of the building, but it was starting to look like an unfinished shed. And now it looks a little bit more finished. We've painted the walls black, and the reasoning for that is because we really wanted to focus guests' attention on the screen in the main room, which is where you start your journey. And that's the focus of that first part of the event, is to draw you into the event with the big, nice, impressive graphics and simulations that we put on that screen as part of the first part of your experience. So by painting the room black, it gives you that desensitized feeling of just having that screen and the presenter there with you, and it hides all the scuffs on the walls because
now we're getting to the bottom of it. Yeah.
We've been open for 16 years, and the walls are scuffed to bits, so it's covered all of that off. We've put some nice protective cladding on the walls as well to hold back the scuffs, and just lifted it up and made it look a lot fresher. In that main room, we've even installed a curtain, so it's like a nice little cinema experience. Now you get that little curtain comes across when we start an event, and the entranceway has been really opened up. So we've ripped out all of the cupboards that we didn't really use and made it a really good open space to walk into, very welcoming space. We've got all 88 constellations on the wall as well, which have been hand painted by Ellie. She spent 7 hours.
I was going to say, I've seen this, and if people haven't seen it, obviously you know that what the night sky, star constellation pictures tend to look like. And I thought, is that like some kind of transfer that you've put on the wall, or has somebody actually spent ages? I'm pleased that it's been painted on, because I did wonder if that's been done in chalk, how long it's going to be before that gets all smudged. But it is impressive.
Yeah, and the accuracy of them as well is beautiful. She even got Hydra on there twice because she was so excited. So there might be 89 constellations. But there's some places to hang your coats as well when you walk in. It's just a much more welcoming, opening environment. And then in the Gillian Dickinson building, we've completely renovated that room as well, changed everything around. Merchandise is on a different wall, and we've got what looks like a mission control of all of these screens on one of the walls as well. So yeah, it's been a great week. We've changed lots of lighting as well, just to bring the lighting down and make it a little bit more atmospheric rather than just bright lights in your face. When we switch on white lights, it was like very startling. We've brought all of that down as well, and just made it a nice fresh environment. And then the exterior of the building, you can actually see the building from the car park now. It was disappearing behind all of the foliage and trees, but we've cut everything back. We had a huge team of volunteers come from Accenture, who gave up their work days to come and support the the works that we were doing, and they did a whole heap of stuff in the day that they spent with us, as well as some of the volunteers who already volunteer with us as well. And they got stuck into weeding, got stuck into gardening, got stuck into cleaning, painting, all of these different things. Oh, we've even changed the colour of the floor as well. For the first time in observatory history, we've moved away from battleship grey, or has it changed its name recently to frigate grey? we now have restoration green, so the floor has changed colour for the first time, and we've got a lovely hedge in the car park which we've created out of all of the stuff that we'd been digging out and cutting down. We've created this wonderful hedge which is a great place for wildlife to hide. It will eventually decay and become a lovely dead hedge. But it also strategically is to block out the light pollution from the car park when people are getting in their cars and all of this kind of stuff. So, yeah, it's been busy.
Certainly sounds like it. Been very industrious. So when people go from now on, you will see these changes and appreciate them. And notice the quality of the shelving that Dan's been working on, that kind of stuff. It's been hard work, and all the volunteers there and all the staff at Kielder Observatory have been all getting involved there to make this spruce it up, as you say. It's been a while since it's had this renovation done, and now all looking spick and span. So you're opening the doors now, people coming in and looking back into the night sky. Now, obviously, we've got fairly still the nights are still the same length, but obviously it's the amount of light you have. And I've noticed certainly driving around late at night, it's sort of 1-2 o'clock in the morning, really, before it really sort of turns properly dark at this moment in time. But you can see the stars coming out. We've got days of roughly 17 and a half hours at the minute. And then by the end of July, we're going to be down to about 16 hours. So the nights are going to start drawing in a little bit more now. And even still, though, you're going to have to wait till fairly late before the real telescoping begins.
Yeah, you do. And this time of year, we strategically always at this time of year, we push all of our events back an hour. So at least we get some of the darkest part of the night. And then, of course, on a weekend, you've got the option of our new event. Pausing because I've forgotten its name. We've got our new event, Late Night Discovery, which is a great event to come to because it's put on at the prime point of the night where we can do some observations. The darkest point of the night is when Late Night Discovery is, and as we start to get into August, that darkness will start to come back. I love August, actually. I think back end of August into September, I think is probably the best. For me, is the best observing season is that time of year because the temperature is still tepid. Although who knows in the UK? Who knows in the UK?
That's as good as it gets at Kielder.
I had my heated seat driving home last night, which I don't think is a thing I've ever done in June. But yeah, it's a little bit warmer, I guess, and the midge is starting to dissipate by that time. And then, of course, we've got the Milky Way coming in as well, and it's just a really nice time of year. To be observing is the back end of August into September. And still loads of availability on tickets for that as well throughout the whole summer. Still loads of availability, but they do go very quick. So as we start to get into July, the first couple of weeks in July, every year the same thing happens. We get a deluge of bookings, which then book out the entirety of August. So if you're thinking about it now, then just go and do it because the tickets may not be there.
Yeah, don't waste time. Get on that. And, obviously the amount that you can see with the darkness, obviously a little bit limited, but there are some standout constellations. And we talked about the summer triangle, I think, in the last episode. We've mentioned it a few times, but it's like the thing to look out for at this time of year. And maybe one of the most noticeable things with the naked eye as you look to the sky and you can see the stars coming out. But just to talk about about the makeup of the summer triangle, really, and what it is that we're looking at there, because it is a notable part of the night sky, and it starts with Cygnus, doesn't it? That's one of the and Lyra, perhaps one of the first ones you might be able to see.
Yeah, it does. And I love the summer triangle because it very obviously is a very ginormous triangle in the sky that you can see. It's amazing. And the one thing that I love about it is these distances of these stars. So it's made up of three very bright stars, which is the Deneb in Cygnus, which I was told once, actually. The Deneb stands for, it means in some ancient form of language or maybe mistranslated language at some point. A lot of star names, I'm kind of deviating from the point here a little bit, but a lot of star names, they're not actually as they were originally pronounced. So they're usually a word in Arabic, which has been mistranslated through history, and then we've ended up with the pronunciation that we have now. So for now, anyway, Deneb apparently comes from the word bum or bottom.
Right, okay.
And it is the back end, is the bottom of Cygnus the Swan. And I love this constellation because Cygnus the Swan is this huge, big swan flying through the night sky. It's got these big wings that are extended out. It's sailing through the night sky. Its neck stretched right out. And it's going right through the plane of the Milky Way. So as it gets a little bit darker at night and we start to get the dark nights really coming back in and astronomical darkness returns, when you look for Cygnus, you'll see the Milky Way runs from you'll see the Milky Way runs from head to toe. Oh, sorry, head to tail through Cygnus. It's like it's flying through the Milky Way. So I love to see Cygnus and its positioning. Looks like a big crucifix. Does most of it. And in the eye of Cygnus, there's a little star right at the bottom of that crucifix shape, which makes up its eye, and that star is called Albireo. And now Albireo isn't actually one star when you look at it through a telescope. It's actually two stars, and they look like they're really, really close together. And it was assumed that these two stars were a binary system, and a binary system is two stars which have formed very close to each other and are now orbiting around each other. A little bit like planets do, but kind of doing this dance around each other. And there could even be planets in that mix as well to make some really interesting orbital patterns. So these two stars, it was guessed that these were just a binary system. They're not, it turns out. They're really far away from each other. They've got a huge separation. They're not related to each other at all. But when you look at it through the telescope, it's still a really interesting star to look at because they're two different colours. So you have a yellowy kind of coloured one and a bluey kind of coloured one. And I think binary systems like this or double stars like this are really, really pretty to take a look at. So there's Albireo right in the head of Cygnus the Swan.
And Deneb is one of these stars that is quite a long way away. It's 2,600 light years away from Earth. So it's that one of those, certainly kids love this. I mean, I find it fascinating as well that you're looking at the light coming from that star, and that light was emitted, really before much of the dawn of time as far as the modern civilization is concerned. It was 2,600 years old is that light that you're looking at, which is amazing, isn't it? Yeah,
I mean, that was a really crucial time for history as well. About 400 BC was a really interesting time. History? No, actually, no. Where are we? 600 BC.
The year is 2024.
That was 200 years ahead there. 600 BC. Yeah, really interesting time in history. And you think that light left there 600 BC and it's arriving right now. Whereas the other stars in the Summer Triangle, and this is what I like about the Summer Triangle, because you look at these three very bright stars, and then you go, oh look, there's Altair. Altair is about 17 light years away from us, and there's Lyra and Vega in Lyra, and Vega's about 25 light years away. So these are relatively close stars. They're bright, but then you go look. There's Deneb. Deneb is 2,600 light years away. And it gives you that real contrast between distance and how the brightness of a star doesn't necessarily dictate its distance. It can be to do with many, many different factors, or a few different factors anyway. It's just Deneb is a very luminous star, very, very bright star.
But it's fascinating, isn't it? That light, was fired out of that star, during the Iron Age.
Yeah.
And all of the stuff that has gone on in the world since then, like the Vikings or the Romans, all of this stuff has happened during the course of these particles of light traveling through the universe to eventually hit our eye now in 2024. It's it's phenomenal.
And that's something that I like to think about when we're looking at things through a telescope, or even just looking up into the night sky, is that we often look past this because we're so used to consuming things from screens. And people often say to us, and I'm sure I've mentioned this before, but people often say to us, why don't you just project from the telescope onto a screen? And I'm like, no. There's a time in which we can do that, and it's appropriate, and we are currently exploring that a little bit more and how we can bring that to life in a very Kielder fashion, because everything that we do has to be it has to cover some core principles that we're trying to achieve as a charity, as an organization that differentiates us from everywhere else. And so when we look at things through a telescope, the reason why I quite like it, looking at it through a telescope, is because it might not look as bright, it might not look as detailed as what a photograph would, but you're collecting photons of light which have been emitted from these things all that way away and have traveled through space for that amount of time. So in this case, when you look at Deneb, there's physical photons which left that star, traveled for 2,600 years of Earth, or Earth years, to us here. They've entered through your pupil, hit the back of your eye, and that's been absorbed by your eyeball, converted to the electrical current that gives you your vision. So you've absorbed a piece of stuff which has come from that star. And I think that is a much more human experience. And what's quite interesting about that little photon is that it's experienced no time at all. So it's existed and ceased to exist in the very same moment for that little photon, if it was able to measure time. And then
it's
it gets
deep, isn't it?
Yeah,
it is deep. It is deep.
Yeah.
There's lots to take in. And then Lyra, of course, is another star, well, another constellation, actually, not star, but Lyra, with Vega being the brightest star in that, and that's one of the first stars sometimes you can see, isn't it? As it starts to get dark, that star twinkling there possibly is Vega.
Yeah, it is. It is. Vega's a lovely star, nice big bright star. Vega is quite a significant star as well. Vega is magnitude 0. And when we measure the brightness of stars, or any objects in the sky, for example, we use the order of magnitude. Vega is 0, and then the higher the number, the dimmer the object is. The lower the number, the brighter the object is. So the sun would be minus whatever it is, I can't remember. But we can see with the naked eye, the sun is about minus 25, I think. That number's just come to mind. But we can see up to about magnitude 6. So if you're ever looking through an astronomical almanac or anything like that, and it says magnitude 8, then you know you're going to need to have a telescope to see that. To be honest, If it's magnitude 5, 6 or anything like that, I would probably say you're going to need a telescope to see it particularly well, because magnitude 6 is at our limit in the best conditions. So when we're in the darkest of skies. And this is particularly important as well if you're looking for comets. So if you see on the news, they say, there's a comet coming and it's going to be magnitude 10. Then you know you're not going to be able to see it with the naked eye. But you might stand a chance of seeing it with a telescope.
Well, on the news, there is a story about a comet coming. You've seen this.
That's a good segue.
Yeah. Well, what we'll do is we'll talk about that soon. I don't want to throw off course of what we're doing and do a full handbrake turn there, but there is a comet coming that you will be able to see potentially in October or around then. So hold that thought. But for you comet fans, something on the way. And yeah, the other constellation, of course, is Aquila. It's known as the Eagle, and Altair, the main star in that one.
Yeah. Oh, actually, just before we move on from Vega as well, worth mentioning. I think I might have mentioned it in the last podcast actually, but Vega is the subject of the '90s film Contact. And the '90s film Contact was, I think, first broadcast on television in 1998. It came out, I think, 1997. So if you are on a planet around Vega, then you'll be receiving the television transmission signals for the film Contact about now, and they may be watching that now and thinking, oh, look, this civilization thinks that there's a civilization around Vega, so maybe we should make contact with them, and then who knows, the reality might happen. The only thing is that film was filmed at the Arecibo telescope. There was a lot of stuff done there, which of course has collapsed now, so it can't be complete reality, but it can be close.
Well, that would be a twist, wouldn't it, if they actually did reshoot it as how it actually turned out. It's like, we can't make contact because, look, guys, the telescope's collapsed.
I'll have to use another one. There's a bigger one now anyway. There's a huge one in China called FAST, which is 500 meters in diameter. It's huge telescope.
500 meters?
Yeah,
wow.
Yeah, massive.
I want to be keeping that one clean. Yeah, okay. Yeah, there's all these telescopes out there listening out for things. Of course, Jodrell Bank, one in our country that's doing a bit of radio telescoping, isn't it? And of course, Kielder has its own radio telescope as well, which you may well see if you should see as you arrive, because it's pretty much unmissable, I would say, as you walk past it. So,
it's nice and clean now as well. It's been washed.
Has that had a wash as well? Good stuff. Yeah. So that's how things are looking. And one thing to look out for then, the summer triangle. Have a look at that and have a look at those stars and wonder at them. Particularly Deneb, which, as say, is just old, really old. Yeah. With that light that's coming into your eye there direct from the Bronze Age. Was it the Bronze Age or the Iron Age? I think it was the Iron Age. Wasn't it?
Yeah.
So, 600 BC, that light set off from its original source. Looking at planets, of course, it's a little bit difficult sometimes to see the planets with the lighter evenings, but there are still some planets around. Mars should be visible or becoming visible. Jupiter is, as ever, knocking around as well, isn't it, at this time of year?
Yeah, it is. Yeah, they're quite late at night, about the early hours of the morning, really. Pre-dawn sky, certainly for Mars, Jupiter and Saturn. That is right.
I think you've got to be up about 3 o'clock in the morning, just before it gets light. So yeah, as you say, late, either really late or really early, depending on your body clock.
Yeah. Mars actually is one of my favourite planets to look at through a telescope as well. I love looking at Mars, especially when it's at its closest approach, because it's the only planet, the only other world in the universe that we can gaze onto the surface of. You can see surface features of Mars through a telescope at certain times, which I think is just incredible. I know we can see the surface of the moon, but it's not a planet, it's a moon. And I know we can see cloud details in Jupiter and Saturn, but again, they're just clouds. You can see the physical surface of Mars, which I think is just an incredible thing to see through a telescope. So, keep an eye out for those. They are arguably the three most visually spectacular planets, Mars, Jupiter and Saturn, because Mars is nice and red. Jupiter's got some features and some good moons, and Saturn, of course, has the rings and moons as well. Venus is nice, but it's just really bright and very featureless when you look at it through a telescope. And of course, the other planets, when we look at those through telescopes as well, they are so far away they generally just appear as these little tiny pale coloured dots. Say, for example, Neptune or Uranus. Uranus is a turquoise dot, and Neptune is a little blue dot. But they're still really amazing to look at because, especially Uranus, I really like Uranus because it's quite an interesting world. And a turquoise dot is what you see through a telescope. We sent probes into space, which took a better quality image of Uranus, and it was a turquoise splodge of pixels. And then we sent something which went sailing past and took a high-resolution photograph of Uranus. And guess what? It was a featureless turquoise blob in high resolution. So it just is a featureless turquoise dot. But an amazing world to take a look in itself anyway. So yeah, keep an eye out for all of the planets, Jupiter, Mars and Saturn, early hours of the morning. Yeah.
Well, on the subject of Mars, an exciting discovery, actually, because there's two spacecraft who have been orbiting Mars. This is the European Space Agency's ExoMars and Mars Express missions have found frost on the Tharsis volcanoes, the tallest volcanoes in the solar system on Mars. So these are big old mountains. I mean, if they're on Earth, they'd be absolutely epic. But they previously thought, the experts, that it would be impossible for frost to exist in that region on Mars. Although earlier in 2024, it was announced that Mars Express had found evidence of water ice at Mars's equator. This frost apparently has appeared in patches. It's present for a few hours around the Martian sunrise, and then the patches evaporate in sunlight. So this is interesting because we've been talking about the discovery of water, obviously would be a major thing. The frost is only as thick as a human hair, so very, very thin layer of frost that appears on Mars, but it covers a massive area. So what they reckon is that if you actually got all of this frost together, around 150,000 tons of freezing water, they estimate at the moment. If they got all that together and then it melted into normal water as such, it would actually be enough water to fill 60 Olympic swimming pools. Whoa. So that's a lot of water. That's many, many gallons of water, and it appears every night and then disappears again when the sun comes up. So they're getting frost on Mars. So. And that's pretty exciting, isn't it? I know it's not a sign of life, not actual life form, but the existence of water has always been a big gauge, hasn't it, as to the possibility of a planet maybe at some point, either maybe in the past or in the future, being able to sustain some form of life.
Yeah, no, water is, as we know, it's a crucial element for life on Earth. But the thing is with water is it's not as uncommon as people maybe think. It is quite a common commodity as water. There's a lot of it in our solar system. There's lots of it in molecular clouds. We can see it in things like the Orion Nebula, for example. There's water everywhere. But there's just a couple of different types of water. You've got what we might call heavy water, which is deuterium-based water. And then we've got water, which we're more familiar with on Earth. And yeah, we have spoke a lot about water on the podcast recently because there's quite a lot of noise around the formation of water in a similar fashion, actually, with asteroids, where you get this very, very thin layer of ice that develops on asteroids or space rock that's drifting around in space. And the way that that's synthesized, just to kind of recap on that, is that so the particles that are being ejected from the sun, the hydrogen nuclei, they're bashing into these rocks, releasing the oxygen that's trapped in the rocks, attached to something else, and then attaching themselves to that. And so you end up with a little hydrogen bond, a little H2O layer developing on these space rocks, which is quite an interesting find because that might be what actually started to bring life to Earth, water to Earth. Because if we were having water delivered by comets predominantly have deuterium-based heavy water, and that's not what we have on Earth. We've got H2O, and H2O is what we're seeing forming on the surface of these asteroids. And hopefully we'll be able to bring somebody on to talk in a lot greater detail about this. And I'm just wondering if that's something that's happening here on Mars as well. Is it that process is happening? Because Mars's atmosphere is very, very thin. So is it that there's a similar process happening there, or is it that the water was already there? And there has been many thoughts in the past, and many simulations ran, which lead to the belief that Mars was very enriched with water during its past, and potentially still has some water left underneath the crust, underneath the surface of Mars. So yeah, really, really good, interesting, amazing load of water. I think the trick is with water, though, you've got to get it all in the same place for long enough, and then you've got to get some molten ingredients to start to mix with that water. A little bit of heat of some description to really start to bring that life to life. Really. But the ingredients, the actual core ingredients, water plus some amino acids and the nuclear bases that you need for DNA and RNA, all of those materials, DNA, RNA, nuclear bases, they're synthesized in space. We see them in carbonaceous chondrites, which was a huge breakthrough over the last 2 years. So that raw ingredient to craft your DNA is there. Then the amino acids are there as well. In which case, if you then add water to that and a stimulant, then you may start to get that process of cell replication and things taking something in and outputting energy. And this is when you start to get, I guess, good life forming.
And obviously they're talking about these mountains that they've found them on. The Olympus Mons, which is a big mountain indeed. The scale of it, though, if people are not familiar, imagine Mount Everest, right? So Mount Everest is the biggest mountain on planet Earth. Olympus Mons is 3 times bigger. It is 72,000 feet high, which is absolutely incredible. Pretty much touching the stratosphere if it was on Earth. That's 13.5 miles high, Olympus Mons, and it's up there at the top of the mountains like this that they found the frost. I mean, to be fair, if all they're getting is a little bit of frost at that height, if that was on Earth, you'd have woolly mammoth roaming around still up there, I would imagine, because it'd be very, very cold indeed, wouldn't it? But that's an idea of the scale of these mountains on Mars. They're just absolutely colossal, aren't they?
They are absolutely huge, and a lot of that is because of the size of Mars. So these structures can get a little bit bigger when the planet's forming. They're not being kind of pulled down by huge amounts of gravitational force. And that's why our planet has a kind of limit to the size of anything that can form on Earth, because gravity is pulling it back down again. It's going to collapse on itself and be pulled back towards the planet. So it can only get so high. Whereas Mars, being that little bit smaller, allowed this huge, ginormous volcano to become constructed, and then whatever happened in the past happened. But certainly what I quite like to think about is when that volcano was active and it was spewing material out of it, Mars most certainly would have had some form of atmosphere at that point in time, so we think. But when it was ejecting material out, those eruptions would have been huge eruptions, which would have most certainly sent material out into the rest of the solar system. And some of that material may end up landing on Earth at some point. And there was speculation as to whether or not the reason why we have some of the Martian rock that we have is because of ejections from volcanoes like Olympus Mons in history, which have then eventually been collected by Earth. But the kind of theory that people prefer, and so I'm told, is that something comes in big, hits Mars, ejects rock away from Mars, and then chucks the rock out into space that way. So yeah, it could be either. I to be honest, I don't actually know how deep anybody's really got with that, and whether or not we have found something that we think may have come from a volcano on Mars. I'm going to have to Google it after this.
Well, you could do that. We've also got an previous episode from actually a couple of years ago now. Maybe it's time to revisit it.
Oh, of course, yeah.
Dr. Natalie Starkey was on in October 2021, which just seems like yesterday, but it's actually a few years ago now. Dr. Natalie Starkey was on the Kildare Observatory podcast then, and she is an expert in volcanoes of the solar system. So listen to that, because it is actually a fascinating episode where she's talking about all the different volcanoes and how the moon used to be at one point covered in lava and all this kind of stuff, and why volcanoes actually are good for us all, because they kick out a lot of ash and all this kind of thing, but that can actually help keep our planet cooler and keep other planets cooler as well. So definitely look out for that one if you're wondering what to listen to next, because whilst it's a few years old, of course, volcanoes haven't really changed much in that time, nor has the solar system. So you'll be able to get a bit of information about volcanoes on that one. Let's just talk about this comet as well, which is it's around and about at the moment. I'm not sure it's particularly visible just now. It was around earlier in June. This is I'm not sure how to pronounce this, but it's the Shushinshan Atlas C/2023 A3 for you comet collectors out there. And this is heading towards the sun. Well, not heading towards the sun, but as far as our eye is concerned, it's heading towards the sun at the moment. So fairly tricky to see, but it should be re-emerging the other side. And by the time we get to around, say, October, they reckoned it could be around the naked eye threshold in terms of visibility, which would be pretty exciting if that is the case.
It would be, yeah. And interestingly, Tsushinshan, I can't even say it either.
Mouthful, isn't it?
Tsushinshan is it means it means purple mountain in Mandarin. Does that? Yeah, it's. But yes, it will be a lovely comet if it's naked eye visible.
Which they're not sure if it will be yet. They're hoping that it might just about be.
Yeah, the projected. They're looking at the projection here around about that very early start of October. It's starting to approach a really good brightness around then. 13th of October, in fact, is when it's closest to us, about 0.4 to 0.5 astronomical units away. An astronomical unit is the distance between us and the sun, so 93 million miles. And this is about half of that. So about 70,000 kilometers there or thereabouts. And it should hopefully, if all goes well and to plan, it should start to reach maybe even Mag 2, which makes it naked eye visible. The problem is with comets like this is once they start to get too close to the sun, comets are constantly going through this shrinking process. As they get closer to the sun, they sublimate. So the ice on the comet, it turns immediately into a gas. It skips that liquid phase, goes into a gas. So they're shrinking and shrinking and shrinking. There's many occurrences whereby when they get quite close to the sun, they're sublimating so quickly that they break apart and you get a separation event. Or in some cases, they just dismantle entirely or end up in the sun, which is what happened to a comet a few years ago. There was a comet Ison, and everybody was like, oh, it's going to be the biggest thing since Hal-Bob, hang on, do that again. It's going to be the biggest comet in the night sky that we've seen for such a long time. And then it got eaten by the sun.
That's showbiz.
And that was it. It was so anticlimactic. So hopefully this one does become a naked eye visible comet, a little bit like the one that was around during the lockdowns. I loved that one. Seeing that was probably, I think that was one of the best things I've ever seen in the night sky, if not the best thing that I've seen in the night sky. Yeah, was seeing Comet Neowise. I just remember driving up the A1 and there it was just in the sky, and I was just amazed by how static it looked. But I knew that it was traveling maybe, I don't know, 80,000 miles an hour through space. And there it was, just sitting there in the night sky, this beautiful long tail just drifting. It's incredible to see with the naked eye. If we get to see it, fingers crossed we do, because I do love a good comet. Oh, yeah.
Okay, well, fingers crossed on that one. Obviously, the danger there is, they do have quite a lot of ice attached, and so if you get an ice cube and hold it over a fire, that can tend to recreate the drama of a comet in the comfort of your own garden, maybe, and the hazards therein.
I mean, I would just open your freezer. That's probably a better way of demonstrating that.
Yeah.
That little cloud.
Open your freezer. Eventually, everything will melt. But hopefully, we'll get past the sun, and you'll be able to see it coming out the other side without it getting too fried. And yeah, it might look pretty amazing in the sky. So, as we head through this portion of the year, then, school holidays are coming up, and, well, goes without saying, you're going to be looking for things to do with the kids. And as we move into July, we move into, peak season for the various family-based events that Kildare Observatory do, because, of course, making your kids stay up until 11 o'clock at night might seem like a good idea, but you'd probably be regretting that decision when you actually get to it. So with that in mind, we do have a number of family events that are aimed at kids that start a lot earlier, that kids can still get involved in, learn about space and all sorts of stuff. And so we've got the Space Kids events, and these start at either 5 or 6 o'clock in the evening. So you've got the Light Year Academy. I'm not sure I know what the Light Year Academy is, actually. I don't think I've... do you qualify as an official Buzz Lightyear and go to infinity and beyond at the end, or what's that about?
You do get a certificate, actually. Yeah, you get a certificate from Light Year Academy to graduate from it. And it's just kind of a mixture of all of the different activities that we do for kids in one event. So it's a really, really great event. It was received we trialed it last year. It was the most popular kids event last year. So we thought we got to bring it back this year as well. Prior to that, I mean, a number of years ago, we only really did one kids event, which was building rockets. But now we've separated them out into different themes, because we can do other things in these events as well, such as exploring exoplanets and designing our own exoplanets, exploring constellations and designing constellations, and all of these different activities we kind of put into one event, which is Light Year Academy. And like I say, you get a nice little certificate to take home with you as well to graduate from it. So it's a lovely event, a really good event.
It looks like a nice happy medium, actually, because I think, there's some events that may be a little bit more sort of advanced for kids, and then you've got the ones that are obviously like the Space Kids with the rockets, which, obviously good fun. I think that's a good little middle ground, that. So that's a good addition. Searching for aliens. Kids love searching for aliens. What's better than sending your kids out looking for aliens? So that's sort of... if they come back with an alien, they get an extra prize. That is that is that's the surprise with that one. And then rockets and more. Well, we've talked about this. Obviously, we've got an episode where my daughter went and actually did this last year, where you actually learn about space and rockets, particularly, and build your own rocket. Which obviously these events end with a traditional launching of the rocket, which is always good value.
Big ceremonial launching of the rocket. Yeah, it's always fun.
Yeah, it is superb. So get on and have a look at those. Through July, through August, these are the events, and you can spot them very easily on the calendar on the Kildare Observatory website, because they're bright yellow, providing, of course, that you don't have issues seeing colours, in which case it might not be so obvious. But they're there anyway. They all start at 5 or 6 o'clock in the evening. We've got lots available, actually, a big wide variety. So go on and take a look. And see if you see something that tickles your fancy. Secret Life of Stars, Discovering New Worlds, The Dark Cosmos, and if you really want to get into the hardcore stuff, then the Late Night Discovery events are happening as well, which begin at either 11 o'clock or midnight for the real night owls there to get stuck into to the stuff when the night sky really truly moves in, and that's for the real eager beavers who want to see something spectacular through the telescopes.
And later on this month as well, we're at the Deershed Festival. This is the first festival that we'll be attending ever, the very first festival. And Deershed Festival takes place in North Yorkshire at Top Cliff. It's on the 26th to the 29th of July. And the headline acts this year are the Coral, Bombay Bicycle Club and CMAT. I think I only know two of those. I'm not sure who CMAT are.
Well, I know the Coral.
We know the Coral.
The Bombay Bicycle Club.
Yeah, I like a bit of them.
And so are the Coral going to be doing some rocking to the tune of some stargazing, or what's going on there?
So we're taking over much of the science tent there, so you can come along and enjoy launching rockets there as well. And we'll be working on a collective art piece as well whilst we're there across the weekend. We're camping out. There's a whole bunch of the team that are going to be down there. And it'll just be a great time. I think we're taking the planetarium as well, which, if it's a warm weekend, that's going to be a sweaty box, but it'll be
it's not a phrase you want to hear, but it's the truth. I think you need to have celebrity rockets for those that performing, see if you can get them along to launch a rocket and then see which celebs who are performing on the stage there, who
build
has
the
it
best
in
rocket.
them for a career in aerospace. Yeah, you never know.
Yeah, that'd be good.
Okay, so look out for that if you go into that festival. What's it called again? The
Deershed Festival. As deer as in like the
deer shed.
Well, deer,
Right.
and they have a shed that you keep them in, don't they?
Yeah, there you go. Does what it says on the tin. Deershed Festival. Look out for that if you're going along and see Kielder Observatory there. And I think we hope to see you up at the observatory soon as well. Hopefully, if you're listening to this and you want to come along and see the new look observatory facilities as well, because everything, as we said, has been spruced up and updated. Then good to see you down there, and book onto some of those sessions wherever you are in the world. Make your plans in advance. And come and see us, and we hope to be able to see you, and we'll catch you again for another episode of the Kielder Observatory podcast soon.
Bye-bye.
Ta-ra.